I've done some mechanical projects before, but this reached a complexity that was definitely new to me. I thought it was gonna take like a week to do, but for everything I make, I work on it like 30 minutes every day for like 2 months. Let me bring you back to where this project started. Across the Atlantic. I was studying for a semester in San Francisco last fall. I'm studying engineering with a focus on design. If that wouldn't be the case, I think there's a parallel universe where I would study biology. The animals on this planet are so diverse, they almost feel like aliens. And it's so hard to grasp the evolution from almost nothing into something looking like this. I want to capture the majestic motion of an animal in a mechanical sculpture. From one circular motion, transforming it into something walking. Why not take the tallest mammal on the entire planet? An animal so weird that they can even sleep standing up. With spots that are so much like the human fingerprint. No two individual patterns the same. I started out brainstorming, collecting some reference images. My first idea, to get the natural motion, was using the Jansen Linkage, a mechanical assembly created by Jansen in the making of his strand beasts. Kinetic, animal-like creatures that are powered by the wind. With this assembly in mind, I made some different versions. But after a lot of different tests, I only got the motion to look good with legs that are more thick. There probably is a way to do it, but I could not manage to figure that out. And as we know, giraffes do not famously have thick legs. I needed a better approach. Tracing the position of the feet of a giraffe when it was walking gave me this kind of shape, and a new idea. An oval shape on the upside, and a flat downside. To get this motion, I played around with another type of assembly that would fit underneath the giraffe instead, and realized that different sizes of the components creates different motions. After getting this motion right for one leg, I duplicated the assembly for another leg on the same side, and then the other legs on the opposite side. To connect these motions together, I used a long link. This decision would later become a problem. But later on that. I made some fake legs from links to see how they would behave with this type of motion. And well, it looks pretty natural. So I screenshotted that assembly, put it into a 3D program and traced the different components. And it actually worked better than I thought. Now it was time to build the actual giraffe. In a 2D vector program, I sketched up the different parts of the giraffe. I want the legs to be able to move naturally, as well as get a small motion on the neck moving up and down. I tried to split up the body into different components, and also see how these components would interact with each other to move more naturally. Basically, where would the components join and have their points of rotation. Once I had a 2D sketch I liked, I screenshotted it, inserted it into a 3D CAD software, and traced the outlines once again. Then I joined the different components and added a rotation to the necessary points. Trying to assemble the two parts went fairly smooth. I realized though that the mechanical assembly was too small, so I made everything more robust. I connected some gears to move the point of rotation further away from the assembly. In the CAD software, the whole project could now move, and I printed it out and started assembling it. Some things fit perfectly, while others required me to use some sandpaper to get it right. While it looked pretty cool, it had some big issues. The thing that connected the front motion and the back one was not in sync. and they could move separately from each other, which put the whole assembly in kind of a deadlock. I also realized that the actual body felt too big and the mechanics felt too small. My only option was then to remake it and make it better. The left side has to be able to move without affecting the right side. My new idea was to connect the moving sticks to gears and attaching these gears together with a smaller gear so they still rotate in the same direction. Mirroring this assembly on the other side and then connecting them together with a final gear. So I modeled it up. I also made the giraffe smaller, created a box around the mechanism, and designed a knob that could be turned. It looked much better, it felt more robust, so I put it into print.
Listen to your favorite tune in your car. Why try to change me now? Time based, but no time for us. Loud bitch, bad boys. You were scared, so you kept me down. I trust my mama. You're no match for my bad karma. Broken shards of glass on our tongues. I'm far too scary to be what you like.
It came together quite nicely, although some small issues, but no issues that couldn't be solved with some glue and a stick. Inside of the box, it felt okay to have these cheap solutions. But one major problem was that the leg was able to bend in the wrong direction. But I realized that if I put some sticks in 2 different places, it would restrict these specific motions. Although I could not let these wooden sticks be there, so I printed some sticks in the same material and then attached them. Another last-minute solution, but that also meant that I was done.
Trust my mama, you're no match for my bad karma.